Welcome, kids. Here we are, lesson 2 of our chapter. So in math, right, teachers always teach you the long way to do something, and then eventually, like, oh, there's a shortcut because there's always a shortcut. Yes, in similarity, there are shortcuts as well. So instead of having to list all your angles are congruent and showing that all your sides are proportional, we now will teach you some shortcuts to make your life a little easier. So the first one that we're going to talk about today is angle similarity. So AA with a little squiggle is angle similarity. So as you can probably imagine, if you have two triangles with two angles that are congruent, that's enough to say that they are similar. Okay? So that's our big idea today. So we're looking at similar triangles with two angles the same gives us similar triangles. I think I just repeated myself there, so I'm sorry. Okay. So let's get into it. Again, what I just mentioned, if we have two corresponding pairs of corresponding angles that are congruent, then they are similar. So again, they have to be in matching spots, but if they are congruent, then we have similar triangles. That is our big idea today. All right, we're just rolling right into it. So it says determine if the triangles are similar. If so, write a similarity statement. So for good and for bad, this is going to rely on some previous knowledge. So we kind of have to use things that we've learned in the past to help us solve these. So right now our goal, we're looking for two angles that are congruent. Our easiest or the most obvious ones is when we have triangles that crisscross like this, we're always going to get vertical angles in the middle. So I know that this angle here is congruent to that angle there. So whenever you get something looking like this, you always have vertical angles. So that's one pair, but we need two. So now we're like, well, nothing's marked, Miss Bundy, you're a moron. Well, okay, you're not wrong. I am a moron. However, we do have those little arrows. Remember, that tells us that lines are parallel. So now we have to think, what kind of angles do we get when we have parallel lines? Well, we always get congruent ones because of alternate interior, alternate exterior, corresponding. And if we look here, we have some alternate interior angles happening. It's kind of your choice. This is the one I saw first. So angle D is congruent to angle F. And so would C and G, that would work too, but we only need two pairs, so now we're done. So now we can say that this triangle on the left is similar to this triangle on the right because we have two pairs of congruent angles, which makes them similar. So we're going to say yes, they're similar. And now it says write a similarity statement. So I'm going to say triangle. My brain always likes to start with the small one. I don't know why, but that's how my brain works. So that's what I'm going to do. So I'm going to say triangle DCE. Remember, the order doesn't matter on the first one. It matters on the second one. And now we got to play the matching game. So what matches D? Well, F does. What matches C? G does. What matches E is E. And now we're done. That's it. Okay, let's try another. Again, same instructions. Determine if the triangles are similar. If so, write a similarity statement. So as we see now, I have angle A matches angle F, 68 and 68. So that's one pair. And now I have 54 and 63. Well, those don't match. But we're smart individuals. We know that we can find that missing angle in those triangles by subtracting from 180. So if we take 180 and subtract away 68 and 54, we should get what? 58 on this one. And then if we do the same for angle E, 180 minus 68 minus 63, we should get 49. So now I'm looking, do I have another pair of angles that are congruent? 58 doesn't match anything, and 49 doesn't. No. So now we can just be like, nope, not similar. And if they're not similar, we can't write a similarity statement, so we're done. All right. Our pictures get a little intricate, a little different every time. So let's first off, we have to decide, do we even see two triangles here? So I'm going to outline them. I have this little guy here. I hope we can see him. So we have that triangle, and then we'll do the big one in green. And then we have the big triangle here. Yes. Okay, so we see our two triangles. So now I'm looking, and if we look, do you guys notice how angle N is in both triangles? When I outlined the green one, I had angle N, and then when I outlined the purple one, I also had angle N, so that's one pair. Now we need to see if there's another pair. Okay, so we first need to find out what this little angle is here. So if we take 180 minus 91 minus 67, we should get 22. So this little guy's 22. And then to find angle M, look at your big triangle. We have 25 and 67 in there. So 180 minus 25 minus 67 is 88. So now if I look at those two triangles, do I have another pair of congruent angles? We're close. 25 and 22, they're very close, but they're not exact. So this is another nope, not similar. Smell you later, right? They're not similar. Okay. Our next one here. Again, I'm going to trace out our two triangles just so we can all be on board together. We have a small one here. And then we got a big triangle. Okay. So we can all agree, I hope by now, that angle L is in both the big triangle and our small one. So that's one pair. And now we're kind of looking like, I don't have any numbers. I know she's going to say something about those parallel lines. Okay, you're right. I am going to say something about the parallel lines. So we do now have another pair of congruent angles because this angle right here, this little guy, is corresponding to that one. Those are corresponding angles. Do you remember corresponding angles? I hope so. So we actually do have similar triangles here. Kind of kids, if you see that you have parallel lines, more than likely than not, you're going to have similar triangles. So we're going to say yes. They are similar. And now we play the matching game. So I'm going to write triangle L, Q, P is similar. Now we play the matching game. What does L match in the big green triangle? Well, L matches L, Q matches M, P matches N. And there we are. Okay, next question. We are going to be able to use our similar triangles to find missing measures like we did in our last section. So we are told, or we can figure out that we do have similar triangles if you just want to make sure. Again, we have that big triangle and this small one. Right angle, that's one pair, and both triangles have angle S. So there's our two angles. So we're good to go that they are similar. And now our job is to figure out what VS is. So for me, again, I'm just going to pick things that match. I like to start with my smaller triangle because that's just, again, how my brain works. So if I start with this small triangle here, what does RT, so 3, what does 3 match on the big one? Well, 3 would match 5. So I'm going to have 3 over 5 is equal to, now on my small triangle, I have side ST here, which is 12. And that matches VS, that whole big side. And now again, we just cross, multiply, and solve for x. So I'm going to take 3 times x and get 3x. 5 times 12, 60. Divide out, x should be 20. Let's try another example. Again, the triangles are similar. They're telling us that, so that's very kind. Again, but we can see x matches j, 49 matches 49. So we do have our two pairs of congruent angles. So they're not lying to us. That's exciting. No one likes to be lied to. What are we looking for? We are looking for the variable y, which is side xz. So again, I'm weird, starting with my small triangle. What's my smallest side? JK, which is 4. JK would match. Ooh, so this is kind of fun. It's like, how do I know what JK matches? So you kind of have to you have to look at your picture, okay? So if I look here, JK is across from L, which is the angle that basically we don't have anything about. So I look at this bigger triangle here. What angle do we have nothing marked? Well, it's Z. And what side is across from that? And that's 5. So you do kind of have to pay attention. Sometimes your pictures, you're not going to be able to tell what matches just by looking. You have to kind of investigate a bit. Okay, so 4 goes over 5. And then I go back to my small triangle. 5 goes over. Let's just make sure. We'll just double check. So if I look here, JL is across from 49. Okay, what side is across from 49 here? And that is Y. And now we just do our same old song and dance of cross multiplying. So 4y equals 25. Ooh, we're going to get a decimal. That's okay. Divide out 6.25. Super. And honestly, you guys, similarity is all around us, then we just don't really think about it. So this is just an example. I know you're not probably going to go measure these things, but someone in the world, like surveyors do this and engineers do this and architects use this, will do these things to help them with their career. For your average Joe, probably not. But there are careers that do use similarity. So here's an example of a situation that could arise. So it says a cell phone tower casts a 100-foot shadow. At the same time, a 4-foot 6-inch post near the tower casts a shadow of 3 feet 4 inches. Find the height of the tower. Again, in math, especially in geometry, a picture is worth 1,000 words. So I'm going to draw a really terrible tower. I don't even know how you draw a tower, you guys. I don't even know if that's what a tower looks like, but that's mine. That's my tower, okay? So it's saying our cell tower. That doesn't look like a cell tower. It doesn't matter. Here's my tower. It says it's casting a 100-foot shadow. So I know this is 100 feet. And we are trying to find the height of it, so I'm trying to figure out what this is. So that's my x. And at the same time, a little post, so this is what my post should look like. I'll just draw a smaller one. A 4-foot 6-inch post, so I know it's 4. Let's do decimals. 6 inches out of 12. 6 out of 12 would be 0.5, right? So I have 4.5 feet, and it's casting a shadow of 3 feet 4 inches. 4 out of 12 inches would be what, you guys? 25. So 3.25. I lied. A third. It's a third. 4 goes in 12 3 times. Sorry. Mental math on a Sunday is hard for me. Okay. So that's our picture. Now we're looking for the height of the tower. So we have to set up our proportion. So if we look here, 4.5, our height of our post matches the height of the tower. And then the shadow of the post matches the shadow of the cell tower. And now we cross multiply. So again, cross multiply 3 1/3 x equals 450. Divide by 3 1/3, 135. So our tower is 135 feet tall. Okay, kitties, thanks for watching. That's all I have for you today. Have a super day, and I will see you in class. Toodaloo.